Good morning, good afternoon, probably morning for majority of people on Earth. Another stream dedicated to STM32MP215F. By intention, I'm not saying MP215 because last week I found another discovery kit with MP237 or 73. Let's check it with a different, I don't know, definitely different MPU, but as well with different features. The kit was armed with HDMI, and I think it was interesting variant, so I want to check it. Before I dig into the design job, which will take, I don't know, 20 hours, I want to decide carefully what to do, because in the middle of the game to change the MPU is not it's possible in the schematic capture phase, but it's not convenient. Obviously I didn't store the web page. I'm thinking if searching history makes sense. Let me check the history. STMMP 257F DK. Yes, it helped. 257F DK is the, but not the GK discovery kit. Yeah, this is the thing. Yeah, you can see. Yeah, there is the MPU, better one. Better MPU, or at least different DDR memory as well, and eMMC instead of the SD card. There is HDMI. There is two USB-A's. So it seems that this MPU is capable of control 2 OTGs at least, or they use a different LAN driver, which can be tied to USB and offer two downstream USBs, which is, for instance, LAN 8720, I think I have used multiple times in my designs, but I don't know. So if you expect, and more importantly, there is another MCU, at least one. So yeah, STM32MP215F, which is dual core. Maybe this MCU runs the Ethernet. I don't know. I don't absolutely know. As I mentioned last time, or in the comments on YouTube, I am a little bit overwhelmed with everything around this MPU. I wanted to create a minimal design, and now it seems that it complicated. The things are complicating. So yeah, I don't know. So let's make a quick check. So let's download the schematic, board schematic here. Yeah. Docs. This one. 57 megabytes of schematic. Hello, Biju. I am doing fine. How are you? So the schematic. This block is interesting. Not this one. The MP obviously in the center. The PMIC probably the same as before. As for MP215, ST-Link. Oh, there is a ST-Link. Oh, the extra. I see. The extra MCU was the this one. Overview. This one is ST-Link. They mention it. Okay, so it was improved by the ST-Link presence. Okay, we don't need it. What else? USB hub. USB 3. Okay. The MP257 has USB 3. There is this hub or multiplexer or hub, maybe hub, you know. This looks like a USB power delivery controller. What else? Bluetooth VLAN. SD card, eMMC, audio camera, HDMI, Ethernet, yeah, RTL, DDR3, probably the same one. I don't know, probably yes. And eMMC, SD card along with the eMMC. Probably on the bottom, because I can't see it on the top layer, on the top side. Yeah, will be somewhere here. Hello from the Czech Republic. So this eMMC 8-bit data memory, data bus. Let's check what's this about. It's some obsolete eMMC. Let's check another ones in the same package. I don't know. I don't want it. I want to design a minimal board, but this is going crazy. This is the schematic of the reference design with the 215F. Obviously, there is no ST-Link and no USBs because the MPU doesn't have, or it does. It does have USB. Here. Used for what? For debugging, or I don't know. It's not OTG, it's I have to check the data sheet. Data sheet. OTG host / device. Okay, so it does have two USBs, USB-H, which is a host, USB 2.5.1, and there is USB-HS, OTG-HS, which is host / device. Two times USB 2.0. Okay. One interface with embedded 480 megabit per second PHY and one USB 2.0 high-speed dual role data with embedded the same PHY. Okay, and the reference design. Hello from the Czech Republic. Thank you for watching. So it seems that the reference design doesn't use the USB-H, which is, I'm sorry, I'm getting lost, which is where is the USB here? Host. Doesn't use the host features. Why? It uses OTG connected to this USB, which is used for power, for powering the device. The MPU uses the CC1, CC2 signals or connects them to the ADC inputs, like to mimic the USB power delivery controller, it seems. I don't know. Maybe it's time to check the documentation of the discovery kit, because it seems that I don't absolutely know what the kit does and what what it does and what it's for. 𝗞𝗶𝗖𝗱 is what? KiCad resources, product specifications, user manual. That seems like maybe a potential source of information. It is downloading? No, no. So here is the manual for the discovery kit. We potentially want to redesign. I don't know why now. Frankly, a complete demonstration development platform for the, of course. As a reference design for user application development, yes, for us. USB 2.0 bus powered. Okay, so yeah, I'm interested in the USBs, because USB is the interface to outside world, not the Ethernet, not the camera interface. USBs, because if we want to design a universal board, we want to connect the keyboard, mouse, I don't know, something. So why they use the USB signals to the bus powering USB-C? So when the 215F reference design doesn't use the USB host, does it mean that the better one uses? No, the better one has USB 3.0. It's a different MPU. Probably more different than it looks like. Mm. 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 Yeah, let's wait for it. USB host is here. To USB hub. Where is the USB hub? Here is USB hub. This is the upstream port, yes, and two downstream ports to the USB-A double connector, yes. It seems that it's I2C controlled, but there are not placed serial resistors, or I don't know what's this, jumpers. So it means that it's not controlled. Some fault signals. Obviously a clock, LED, bias, or USB, and ESD diodes. That's all. This is I don't know what. MOSFET dual switch. Yeah, of course, switching power for the USBs, A's, for the USB A's. That makes sense. Okay, so the switch, the hub is only for USB 0, USB to 0, and the USB 3 is for what? For the Type C only. AI camera. Oh, there is a DSI to HDMI converter. ADV7535. Easy to source. Okay, I thought that it's a native HDMI. Not, it isn't. Okay, so the main advantage is zeroed because then the IC is not possible to buy. It's a useless thing. Okay. Okay, so now the thing is, I want to keep the thing minimal. So what else can be removed? M2 connector. Here. I don't know. LCD definitely will be removed. We don't need LCD. As we said last time, I don't know. I don't know. I don't know. I don't know. I want to keep it simple, but yeah, when you see the LCD connector here, just a connector and booster, so not a big deal. So let's use it. When you see the M2 connector, it's just a connector and bunch of signals. Of course, two voltage translators, but it's not a big deal. So yeah, not a big deal. Let's keep it. And the result is what? The result is the stupid copy of the reference design. When I spent, I don't know, 30 hours of useless work, because I don't know, I will make a bunch of mistakes and it won't work. And yeah, I want to keep it minimal, not to minimize mistakes. There will be mistakes, probably yes. I want to keep it like real, reasonable, not to create something useless. And I'm thinking now that I am going nowhere. So what to do? I don't know what to do. What's my first intention? My first intention was to design a simple thing with the DDR3, 4, I don't know, 1525 in KiCad. So the minimal MPU is the STM32MP215, according to my previous research. I don't know if it's still valid. Yeah, I asked Gemini to list all the differences or main differences. Yeah, it seems that there is something like Edge AI, one Cortex A35 core extra. The core is faster, the real-time core, and there is video codec, wider DDR memory, high-speed PCI Express Gen 2, 3 Ethernet gigabits, and instead of parallel RGB, there is 𝗞𝗶𝗖 4-lane. So an overkill for us. So yeah, my intention is not to create something so complex. So 215F is our horse. And now the question is what to remove and what to keep. We want to be able to boot the OS from the SD card. So we have to keep it keep their SD card. Of course, there's no question. Power PMIC, no question. Expansion connector for the Raspberry Pi will be removed. Peripherals can be kept because there are 4 keys, boot mode configurator, and a bunch of LEDs. Not a big deal. We need something like this for debugging, so we need it. DDR4, of course, this is the main thing. Ethernet, question mark, number 1. MP connector, question mark, number 2. LCD connector, question mark, number 3. Yes, that's what I'm talking about. Let's discuss each point. USB audio removed. USB bus powered thing. Yeah, we have to keep it because there is something inside of the code of the MPU controlling the CC line. So who knows how it works? I don't. M2 connector. It's great for connecting communication boards, Wi-Fi, Bluetooth, GPS, you name it. Ethernet connector is great to connect the thing to the local network, to be able to SSH the thing and to control it from your computer, not from the local peripherals of the MPU 215 or MP215. So it's a good thing because this reference board doesn't have any communication interface. So yeah, it has not more than one, not just the Ethernet, not any other communication interface. So if you want to connect it to some network or some computer, you need the Ethernet because there are no USBs. You can't connect the keyboard or mouse. It seems that it's only network connectable, which is something that drives the need of keeping the Ethernet driver. Okay. I'm not very happy about that, but the Ethernet is not a big deal. So, okay. M2 connector. M2 connector is great for many things. MMC, UART. Yeah, as I said, GPS, Bluetooth, Wi-Fi. LCD will be removed. One thing that can be used is to use the high-speed connectors as for Compute Module 5 or Compute Modules by Raspberry Pi. So all the fast high-speed signals can be distributed on the high-speed connectors. But I don't want to create a universal compute module for something, definitely for something, but at the end at the end of the day for nothing. So yeah, that isn't my intention. So LCD will be removed. Final call. M2. M2 should be kept. In my opinion, should be kept. There is a bunch of signals that will be a painful PCB layout, but painful in the meaning of, yeah, bunch of signals, a lot of signals, so a lot of layers, expensive PCBA. So I think they use 6 layers at least, I think. And there are no PCB details. There is only BOM, but I think at the end we can download the manufacturing files here. Let's check it. It's important, because if they use 8 layers, it looks like it's a minimal or optimal, at least optimal. But we don't want to design 8-layer boards. Manufacturing. Let's dig into it. Top overlay, solder mask, top layer, so number 1. Signal layer number 2, which is reference plane. Signal layer number 2, which is the 3rd layer. Signal and no, this is power. Bottom layer, so 4th. Bottom solder. Solder paste on the bottom. Silk screen on the bottom. 4 layers only. Here is the stack up. 4 layers. They use only 4 layers. 1 reference plane, 1 power plane, and 2 signal layers. So all the thing happens on the entire thing happens on the bottom layer and top layer. You can see here is the routing between MPU and the DDR4. So here is the fan out between memory and MPU on the top, and a little, just 1 difference pair and a few single-ended tracks on the bottom. Okay. It seems good because it seems to be good because 4 layers is definitely something we can live with. We can design. It means low expensive manufacturing. It means, what's the manufacturing limits? Whole size to 0.2. The rest of them are rather bigger, so yeah, majority of vias are 0.3. The vias with symbol A are small ones, definitely. Yeah, you can see here is the block. All vias below the MPU and all the vias for the DDR3 are 0.2, which is expectable. Do they use? We have to open the Gerbers if they use the vias in pads or not. So hi, I don't know. Probably some issue on the path between you and the LinkedIn servers. I don't know. I don't have any feedback from all of you, but this one. So I don't know. Can you see my screen? Please comment if possible. Gerbers. Here are our Gerbers. So the goal, my goal now is to check if there are. Thank you for the confirmation, Jabir. So I don't know, Mohammed. Probably there is something in between you and the LinkedIn servers. Try to refresh browser, or I don't know. Maybe some speed issues. So let's open the Gerbers. Yes. So we have to identify the drills. It seems that there are no vias in pads, which is good, which is a good message. The size of the PCB is, where is the size? I have to measure it. (104:73). Hello, how are you? Hello from the Czech Republic. Okay, so 104 times 73. Yes. Let's check the price for fun, just for fun. So we want 4 layers, 103. So it's important. It's bigger than 100. Because for obvious reasons. And we have the minimal drill of 0.2. Where is the minimal hole size here? 0.2. High precision PCBs. Okay. We want 𝗁𝗍𝗃, yes, and this can be our, yeah, $82 can be price for the PCB. So this is nothing super crazy. If we go to 0.15, which is the finest, the price is 100. So the difference between 0.2 and 100 is $18. If we stick with the standard drill, the price is the same as for 0.2. So there is no, yeah, there is no reason why to keep with 0.25, and the 0.3 is $17 only. So yeah, 0.15 is a doable, but 0.2 is optimal. Yeah, I understand why they do that. Obviously, they didn't order a GLC PCB, but yeah, the Asia manufacturing profile says that it's not an issue. Okay, so they don't use vias in pads, which is a good message. Basically, we could copy the entire fan-out, because when we will use the I want to navigate to, yeah, in the regardless files is the here. If we keep the same vias, I don't know what is the size of the via. There is a whole size of 0.2, but I can't see the via size. Tracks are 0.1. Yeah. Yeah, I already closed the GLC PCB, but I think 0.1 is not a big deal. Let's check it again. Where is the minimal? It will be somewhere here. Capabilities, rigid. Drilling traces, 0.1. Okay. Okay, I think it will be more expensive than the advised or announced price. 4-layer here. And 𝗁𝗃. Yes. Yes. Thank you for the confirmation. Thank you. So yeah, so the PCB could be ordered at GLC PCB. That's fine. So as you can see, the camera interface uses this power pairs, the signal pairs, differential pairs. Here is the display thing connected on the bottom layer. Here is the M2 thing connected on the bottom layer as well, probably. Hello, thank you for the question. Yes, I do. Please let me show you. Not here, but here. Yes, I do. As I said, I have two options for you. Last year I created the KiCad for beginners, which is the essential course for beginners with KiCad. Yeah, if you want to start with KiCad, or if you are coming from another EDA tools, I can recommend this. You will get into the symbol creation, footprints, 3D models, schematic capture, PCB layout, of course, manufacturing data export, everything essential. Now there is a thing that if you enroll to the course, you will receive within 30 days a coupon you can redeem at next PCB, and you will get not only the coupon covering the PCB, but covering the entire PCBA, so including the components. It's valid for both my courses. So KiCad for beginners are essential course, and KiCad for makers is the course for, let's say, more advanced users. You can design this board with dual-core 𝗵2350, 2 power supplies, 4 analog inputs, M2 connector, 2 USBs, SD card. Everything is there. So you will start with the reference design for the M2 node cards, and then redesign everything. Like what makers do. Makers usually don't start from scratch. They adapt something, like adapt reference design, modify them. So you will learn this thing. And the thing is the same. When you enroll to the course, you will receive a coupon covering the entire PCBA, so PCBE, plus the components at next PCB company within 30 days. So yeah, I can recommend considering buying for beginners if you start with KiCad, and if you want to move forward or further, KiCad for makers, or both of them. It's of course the best choice. You can visit my profile on LinkedIn. There is a contact info below my photo, and then you can find my contact info there. Sure. So let's get back to this thing, and I think I will need a short break. We are 15 minutes into the show, and I need something to do. So yeah, thank you. I will be in a minute. I'm back in a minute. Thank you for your patience. I'm back. So let's get back to work. So we verify that the manufacturing cost is reasonable for 4-layer board with 0.2 drilling. Now we have to decide what to keep and what to remove from the original design. When I see the gerbers, the bottom, this is power layer. Here is bottom layer. When I see the bottom layer, and top layer, here are two layers with signals. So when I see them, it's really nothing crazy. We can easily replicate it. 0.1, 0.1 tracks clearance is a normal thing, and with it, it's doable. So I think I will keep the Ethernet. Yeah, don't get me wrong. I don't think that it's not possible to do it in KiCad. I just counting hours needed, and yeah, as many. The more components is there, the more probability is for mistakes, and yeah, the manufacturing cost and component cost and everything. Yeah, the more components is there, the more expensive is the entire thing, and I will pay for it. Nothing will pay for my designs right now. It's not something I can sell. Yeah, etc. So the M2 connector is low expensive, and the routing is simple, so I will keep it. Ethernet is something that we need, because without the M2 extension boards, there is no possibility to connect any peripherals on USBs. There are no USB connectors to connect keyboard, mouse, etc. So we need an SSH or UART debug console. So the Ethernet, let me check the availability of the IC, but it's microchip and usually well available, including the documentation. Yeah, it's a cheap chip, so will be kept. Of course, what's an issue is the DDR. Last week it wasn't available. And I don't know if they unlisted the, I think I checked. Unable to accept the orders. Sure. I think Mauser unlisted the memory, because I think last week it was there. It's DDR4, but they say wait. They say on the here on the STE that we can use SDR DDR3 because of the shortage. Here. this one. This is the only one. Yeah, as you can see, issues everywhere. It's 3L or just 3? 3L, yes. This one. Okay. I will do it after that, but it's a completely different chip, so I don't think that the OS will work without customization, and the memory is rather important. Yeah, this is the original chip. Yeah. On the more complex chip, there are more variants for 3L, even for 4. Let's check the availability. They have even the eval board for, I'm getting lost. Yeah, these DDR4s are available. And they say eval board. Discovery kits. Here. Oh, they use 2 of these. eMMC, octal flash memory probably, ST-Link. Okay. Let me check the schematic of this evaluation tool, just for my interest. It contains, oh, this is revision. No. D, E, and D board, E board, ED board. Yeah, the flash memory, eMMC. I'll start with the D, D2. What's this about? Still downloading now. This is the EV, yes, the memory. No, here. Yeah, two chips sharing the same bus, address bus. Differ in the data lines, obviously. DQ0 to DQ31, and this is the 215. Can we place two chips as well? This is 16-bit interface only. They have only 16-bit interface on 215. So okay, I understand. Now I understand. The better chip have 32 bit data bus, but the 215 has only 16-bit. Okay, so just only one chip can be used. One DDR3 chip. These are DDR3s, yes, DDR3s. And here is say hello. Say hello. Okay, so we can use the DDR3, one of them, because obviously we can't use 8-bit chips because there are not such chips. Okay, so well available. I don't know if it's reasonable to design this thing. Obsolete. They say DDR4, but on the here they say it's DDR4. I was wrong. DDR4. Oh, on the eval board. I see. So if we check the DDR3, which is 16 bits as well. Okay. Win bond. This board, this memory is available. Oh, poorly available, but very inexpensive. And in different, zero on stock, okay. And it was so it was DDR3, and this DDR4. I can't remember whether I checked or not. Yes, it's available as well. Available. When I say available, it means that it's more than zero on stock. Yeah. $25 piece. It's the same organization. 4 gigabit only, but yeah, to 512 megabytes. I don't know if the thing will work with it, because the original DK board has 4 gigabytes and the eval board has 2 gigabytes. So this is 4 times slower memory density. I'm getting lost. It's 4 times lower, and the price is almost 4 times lower as well. So yeah, it's reasonable. And yeah, we say that they use 2 chips because there is 32-bit. Yeah, it's more than 4 times more expensive. It's like 7 times more expensive. But yeah, the eval kit uses this chip in dual mode. Like 2 times bigger memory density. To me, it seems that the reasonable thing is to use either this one, which is DDR3 for $27, or the DDR4. This one. And the reason for it is that they verified the the usage at the site of memory manufacturer. So it means that it's not verified by STMicro. Will it work? Let's check other possibilities on stock. And we need times 16 organization. So this, and probably this. Memory interface. So I'm sorry. Parallel, okay. Then So we can spend a fortune on a chip with 4 GB of memory density, memory size, or if we keep the I should remove this technology limit. Yes. Yes. Okay. So again, what's the speed of the thing? 933. Yeah, this is the original chip of the, or alternative chip for the, yeah, this one. Yeah, that was verified by ST. So this is like reference 933 or higher. Yeah, there are some chips available, but not verified by the here, not validated. And then as you can see, there are some 8 gigabit options for reasonable, not reasonable, for a normal, achievable price. And it's a DDR4, yeah. This one looks like a reasonable thing. It's on the list. It's verified. The price is okay. The memory size is, of course, 1 gigabyte only, but yeah, better than nothing. It's DDR3, which is why the memory is still available and let's say inexpensive, if I can say this with connection to the current situation on the market of memories. AI machines don't want to use DDR3, so this is why, or mainly not. using DDR3s. So yeah, it seems to me that this is our horse. And speaking of devil, what is the availability of the MPU? Yeah, VRP, this is our thing, yes. And the availability of the MPU, I'm expecting issues as well. Microprocessors. Looks good. Looks good. I think from the last week it changed. FAL3 and FAN3 are available, as well as FO3. I don't know absolutely what's the what does it mean. So let's check the datasheet. This is what? This is the development kit manual, is it? Yes. No, yes. We can close it. Here is schematics of the eval kit. We don't need it. Here is datasheet, yes. So we need ordering. Order ring. Here. FAM is the 0.8 millimeter. Easy to fan out, but the DK, yes, the DK use FAN3. So the DK use FAN3. FAN3 is 0.5 millimeter, and they were able to finish or to create PCB layout with 0.2 holes. And FAN is available. This is this one. So if we use FAN, we could copy the layout as is, and as well available are AN, AL, and AO. AL is a different different organization of balls, and AO as a smaller pitch, a smaller chip. I'm working on a redesign of the Discovery kit, and I would like to benefit from the existing layout because of minimizing the errors and mistakes. Of course, the layout won't be the same, but won't be the same because the original design uses DDR4, and this chip is either unavailable or crazy expensive, so I decided to use the DDR3 chip, this one, DDR3L, yeah, this one, and it's a half of the size of the memory, and I think slightly different layout because of the different architecture, but 16-bit data and 8-bit of the shared and control signals. So yeah, so FAN3, because of the same architecture. And what's the availability of this thing at Mauser? So I don't know if I answer to your question. Yeah, I will be designing the DDR traces from STM to the chip because the original design can't be copied because it's not possible because the memory chip is different. I can see that on 𝗲𝗀𝗀, the availability of this thing is, so let's say that I will order one, and I can order or put in my basket as well. And show me my casket. I don't need these. And what's another thing is the 𝗶𝗶𝗖𝗱. Yeah, the 𝗶𝗶𝗖𝗱 is here, and because of the power, I will buy two, because sometimes it can be issues with it. There can be issues. So it means that not this one, Ethernet. Yeah, as we saw, this is well available, cheap, inexpensive as well. What's there again? This is the NPU, this is the power, this is something I think MOSFET, or what we say, or eFuse. No, this is the buck. We can use, or we can buy them. So again, the NPU is here. 𝗶𝗶𝗖𝗱, okay. The buck converter is here. The NPU, power block, memory already in basket, Ethernet in basket, connector, not an issue. I will probably use the same MOSFET as here, if it's available. No, it's current monitor. Ah, okay, not MOSFET. Yeah, it's eFuse. It's eFuse. What else? The ESDs will be always available. We say that display won't be used. SD card connector, no problem. ESDs, no problem. Camera interface won't be there. Audio won't be there. Expansion connector won't be there. M2 connector. I think it's a standard KE M2 connector, not a biggie. I think I have some on stock. Voltage translators are commodity, but commodity components, and this is it. So as you can see, when I placed all the components at 𝗲𝗀𝗀 to my basket, it means one DDR3, one NPU, and two of each 𝗶𝗶𝗖𝗱, Ethernet, buck, and eFuse. It's $61 because I will probably add something to save for the shipment. So yeah. It's not for free, but it's still half of the price of the DDR4 chip, which is crazy. So, okay. So we have a plan. M2 connector will be used. USB UART, of course. DDR3, of course. Yes. So we have a plan. So now design work. We are 1 hour and 30 minutes in the show. And what else? What can be done? We quoted at the GLC PCB that the price of the 4-layer PCB with 0.2 drilling, 0.1, 0.1 traces clearance is $87 or $88 for 5 pieces, which make me think that I will order 2 MPUs and 2 memories, which will get me to the better price area. Yeah, you can see 104 euros, and roughly we will have all major components for 2 pieces. So it means that including the PCB for $88, we are at $192 for 2 pieces, including the PCB. I can't count the rest of the components because majority of them is on my stock and or easy to buy. For instance, the M2 KE, I think I have some. KE, this one, I think I used this connector before. Let's check if the same 74 pins, including, yeah, 74 pins. Yeah, this is it. The shield is 75. Why 75? It's a dual connector. Yeah, 75 here. Yeah. It's not dual. It's asymmetric. Okay, so this one. So if we check the price or availability of this one, I don't know if I have one stock or not. $3, 2.3 euros. So I can buy 2. So yeah. So I can even add it to our to-do list. Yeah. No, I will manufacture the board by myself in my lab here. So I just, yeah, maybe you can see my process, my workflow as the opposite, but before I I start, I want to know that my components are available. The situation on the memory market is crazy these days, and I don't want to spend 30 hours of design work and hit the wall at the end because the chips are not available. So I decided to allocate them as soon as possible and then to work on the design. So what's your opinion to that? Is it reasonable or am I stupid? Please tell me. I am serious. I am asking you for your opinion. So yes, again, we have all components in the basket for 2 boards. It's still reasonable. Yeah, it's not inexpensive, but yeah, it's only money and nothing more than money. So yes, I think it's a plan. I think it's a plan, at least for the next time. Yeah, I will check in the rest of the time. I will check the symbol availability at at Ultra Librarian for the DDR, just for the sake of if we can benefit from the community libraries. So Ultra Librarian have this chip. Yeah. Let's speak only about the footprint at the 3D model, because the symbol is, of course, stupid. I don't know. It's a machine created, but I don't know why. Here is the 𝗬𝗲𝗀, 𝗬𝗲𝘀, and yeah, this is how the symbol should look like. Yeah, the logical symbol, not the just copy of the footprint. Okay, so 𝗬𝗲𝘀 have 3D model, symbol. So 𝗬𝗲𝘀 symbol plus footprint, Ultra Librarian 3D model. 3D model is generic, so it's not important, but I don't want to look for the entire search the entire internet for it. Ethernet, I think it's in the KiCad library or not. Yes, it is. So we have this in the KiCad library. The footprint is very simple. So the Ethernet, I'm blind. KiCad library. The M2 is created, or let's say my library. USBs, of course, my library, the eFuse. Yeah, the eFuse. The eFuse is the eFuse is this one. 𝗬𝗲𝘀 doesn't have, and Ultra Librarian have. Symbol is it's TISA23-8, so standard. So probably I will do it. UART, it's just a header or connector, micro SD. My library, peripherals. Yeah. Okay, that's a plan. We have a plan. We have a basket to be paid for 110 euros for 2 boards, but yeah. What can we do? I hope it will work at the end in 3 months or when. Okay. That's a plan. I will conclude this session. I'm sorry. I want to express my apologies to everyone who were expecting me working on the design. It's not a small project, and I don't want to dig into the design and then hit the wall later, as I explained. So thank you for your patience. We created and polished the plan, and we have a plan. We have a plan to use the same MPU as in the Discovery kit, the same PMIC, of course. We decided, because of the price, to use the lower memory density but available DDR3 chip, different from the original one, but verified by the ST, validated by STMicro, to be used with MP2.1, which is our thing. So it should work, and the OS is a different story, but we will see. Ethernet the same as was, and I decided to keep it because of the usability of the entire kit we are going to create. M2 will be kept because of the universality of this, and because of the PCB. The original PCB is 4-layer only, and it means that it's let's say reasonable to keep it. And one thing is that both the DDR and MPU are BGAs, 0.5 millimeter pitch, which is nothing pleasant to manufacture, but we will do our best. Yeah. Well, as I said multiple times, if we want to work on this design, we have to have the components on hand. So yeah, as this question is absolutely valid, but I can't spend like 3 months of design streams and then can't order the manufacturing because of the component shortage. So if I want to work on this design, I have to manufacture it by myself. And if I want to work on it, I have to have already the components on hand in advance, because yeah, I'm repeating myself. So yes, it will cost some fat and some money and some blood and some sweat, but it will pay off. It's a cool thing, I think, to design something like this using KiCad, because everyone says KiCad can't be used to DDR3 or 4 routing, or it's if can, it's painful. It will be painful probably, but we will do it. We will see. So okay, thank you for being here. Thank you for your patience. Next time I will work on the symbols. Maybe if I find a time for it, I will work offline on the symbols, because at least the ones from 𝗏𝗏𝗺 will be or 𝗏𝗏𝗃 will be faster to obtain. So maybe I will do some homework. Thank you. If you want to support me and if you want to learn KiCad, you can consider enrolling the KiCad for beginners tutorial or KiCad for makers. Makers is for more advanced users, but it's not something you can't do. In both tutorials I start from scratch, and you will understand everything. It's step by step, essentials in the beginners and more advanced thing in makers, but both courses can be enrolled by beginners as well. It's now no rocket science in there. Thank you for being here. Thank you for watching. Thank you for your questions. Thank you for your comments. I'm always happy seeing you commenting and asking questions. It was a pleasant time. Thank you, and have a nice rest of the week. See you next week. Bye bye.